important parts in the transmission. The precision machine teeth on these hardened steel components transmit the truck engine's power to usable speed and torque ratios. Sometimes spur gears fail in service, but failure is less likely in twin countershaft Fuller transmissions because the actual load is distributed among a set of 3 meshing gears. Signs of changes or distress on gear tooth surfaces may suggest that a gear needs replacing, but most often these surface changes may actually heal over with use. Gears that appear to be getting ready to fail may give many more miles of trouble-free service, especially if the transmission is going back into the same type of use. This program will help you to identify common gear problems, to determine the cause, and to decide by visual inspection whether certain gears should be replaced during a rebuild. Let's see how Fuller gears are designed and manufactured to minimize problems. The engine's power is transmitted between gear teeth in a sliding motion, then a rolling motion, then sliding again as the gears rotate. A thin film of lubricant is carried through mesh to prevent metal-to-metal contact. Because most loading occurs at full mesh, gear tooth profiles are designed to minimize wear caused by sliding motion. Since it's impossible for any manufacturer to make every tooth profile exactly the same, manufacturing tolerances have been established that will not shorten gear life. Although different gear teeth may vary slightly in shape, each surface must fit within specified tolerances as shown in this diagram. Gear teeth are designed with their pitch lines parallel to the center line of the shaft. The angle between pitch line and center line is referred to as lead. As with tooth profile, tolerances have been established to allow meshing of gears with slight lead variations in opposite directions. In addition, Fuller transmission main shaft gears are crowned or curved slightly to prevent heavy loads from being concentrated on the ends of the teeth. When you hold a new gear in your hand, the tooth surfaces or flanks appear relatively smooth. But if you compare a gear flank with a bearing surface, for example, the gear is relatively rough. Let's look at part of a pilot bearing surface under a microscope, magnified 600 times. You can see that even the smoothest looking surface contains irregular hills and valleys. This gear tooth flank on the right, also magnified 600 times, shows how irregular the surface of a gear can be. Keep in mind that in both examples, the area you're looking at is only 5/1000ths of an inch wide. Surface irregularities can be a wear factor when gear teeth slide over one another. At any time within the life of a transmission, the gearing may have to adjust to different operating conditions. In fact, the gears are constantly readjusting to one another, resulting in changes in surface appearance. These changes in appearance should not be considered a problem, and no strength or life is lost when they occur. One of the most commonly observed changes is what we refer to as frosting. Frosting looks like a band of whitish discoloration starting near the bottom of a tooth, but it is really a concentration of tiny pits resulting from the removal of slight variations in form as the teeth adjust to a common pitch line. Frosting is quite normal and should not be a reason to replace a gear. In normal service, the band of frosting will usually be replaced by a very shiny area. This normal polishing process is called healing and does not reduce gear life. Frosting may occur on other parts of the tooth when mating teeth are within tolerances, but have lead variations in opposite directions. Slight wear, called offset frosting, may take place until the load is evenly distributed across the entire width of the tooth. Then healing should occur with no further wear. Initial pitting is another result of normal changes in gear surface. Lubricant fills the irregularities we saw in the microscopic views of tooth surfaces. But sometimes, under repeated heavy loads, the oil pressure developed between teeth may start small surface fractures that eventually break out to form tiny pits. Slightly rougher than frosting, initial pitting will not cause noise, and, like frosting, usually heals over. This gear shows both frosting and initial pitting, but it should not be replaced because both distress signs are likely to heal over without further problems. Because the fuller twin countershaft design distributes the load more evenly over a set of 3 gears instead of only 2, we sometimes see combinations of minor distress forms or acceleration of healing not normally seen in a single countershaft transmission. There are several factors that may cause progressive forms of surface distress. For example, inadequate lubrication can cause frosting and pitting to advance to a more severe stage instead of healing over. Because of this, it is extremely important to use the correct type of lubricant. Be sure it is of adequate viscosity. Maintain proper lube level, and change lubricant at recommended intervals. If you tear down a transmission that has had considerable use, you may see moderate pitting as shown here. This gear has pitting about twice the size of initial pitting on approximately half of the tooth surface, and it has lived about half its expected life. The teeth have not been weakened significantly, and there is no danger of breakage. As with gears that show frosting or initial pitting, this type of moderate pitting will not cause a noise complaint because the overall involute or curved form of the tooth has not been affected. This gear also has pitting on approximately 50% of the tooth surface, but unlike the previous gear shown, this gear should be replaced. The pitting is concentrated at the pitch line, which changes the involute form. Although the teeth have not been significantly weakened, noise can be generated because the involute form no longer falls within the tolerance band discussed earlier. This gear should be replaced because noise and fatigue fractures may occur. Notice that the pit craters are much larger and deeper than in moderate pitting. This kind of destructive pitting can cause very serious problems. You've just seen, in destructive pitting, one example of the kind of distress sign that means the gear should be replaced. Let's pause for a moment and review the factors to consider when deciding whether to replace a certain gear or reinstall the old one. The first thing to think about is how much longer the transmission is expected to be in service. The second factor is the kind of service. For example, in a transmission that is expected to give 500,000 miles of service, you find moderate pitting of the main drive gear at 300,000 miles. If there is not a noise complaint and the transmission is going back into the same operation, there should be no reason to replace the gear. On the other hand, rougher driving conditions may increase wear. If a transmission previously driven under moderate highway conditions is going to be rebuilt and installed in a truck operating under more severe conditions, then gears that are already showing signs of advanced stages of distress cannot be expected to wear at the same rate as in the past. Another factor is noise. If a noise complaint has been traced to a particular gear set, the noise may be a sign of future trouble. The entire gear set should be replaced, regardless of its appearance. Finally, if you don't know the past history of the transmission, its application, any previous noise complaints, its expected life, then questionable gears should be replaced. We've looked at examples of minor and progressive forms of gear tooth surface distress, problems that may not require replacing the gears. Now let's examine the kinds of trouble that always require replacement, replacing not just the single distressed gear, but the gears it mates with as well. This is spalling. Extreme overloading for a short period of time can cause these craters, which are similar to destructive pitting, except that the pits are wider and shallower. This gear and its mates should all be replaced. Scoring, as shown here, is caused by high-temperature metal-to-metal contact resulting from insufficient oil film between mating teeth. The extreme heat causes an alternate welding and tearing of metal, which is rapidly worn away from the tooth surface. Replace. Burning is another problem resulting from extremely high operating temperatures. When inspecting a transmission with a burned headset like this, It's not unusual to find the main drive gear badly scored, with only slight visible damage to the mating gears. This difference in wear occurs because the teeth of the main drive gear make contact almost 3 times as often as the teeth of the mating countershaft gears. When replacing a burned main drive gear, also replace the mating gears even if there is no visible damage. Finally, there are 3 types of fractures that always require replacement. When a gear tooth breaks out, not only will that gear fail, but loose pieces of metal can cause further serious damage to other parts of the transmission. The 3 types of gear tooth fractures are impact fractures, fatigue fractures, and stringers, or gas pockets. Here you see an impact fracture caused either by a shock load or by a foreign object passing through the gear mesh. An impact fracture can be identified by a bump on the compression side of the fractured area. The more cycles the gear has run after the fracture, the smaller the bump will be. In addition to the gear which has a tooth fracture, the other 2 gears of that set should also be replaced, even though they may look undamaged. All gearing should be inspected for possible damage caused by the broken tooth running through the transmission. Fatigue fractures like these are caused by extremely high stresses on a gear tooth over a period of time. Fatigue fractures are identified by beach marks on the fractured area. These marks are made as the tooth progressively cracks under a load heavy enough to enlarge the crack, but not great enough to break off the entire tooth at one time. Finally, stringers or gas pockets are the result of undetectable flaws or weak points in the metal the gear was made from. These fractures can be identified by the differences in fracture shape and metal texture in the brake surface. Again, as with other fractures, it's very important to inspect all gearing in the transmission for possible damage caused by loose particles of metal. You've seen examples of the major kinds of spur gear wear problems that you're likely to encounter in a normal transmission teardown and rebuild. Remember that these wear or distress signs are typical, but they may not always appear at the same time in the life of a transmission. For example, frosting, a normal occurrence during break-in of a new unit, may be found occasionally at high mileage. No failure will occur, and as the gears continue to readjust to one another, the distress is likely to heal over. The more severe examples can occur at any time when a transmission is operated under adverse conditions or is subject to abuse. We've tried to help you diagnose common spur gear problems. Your mechanical skills, along with the information in this program, will help you determine what caused a specific gear tooth condition and whether that gear should be replaced.